Lesson 43, solving systems of linear inequalities. Alright, we have solved systems of regular equations. Alright, we have done that by graphing, by using the elimination method, by using substitution. I believe we've talked about using matrices to solve those. Okay, those are all fine for regular equations, but when we have linear inequalities, that's going to give us a different type of solution here. Alright, first of all, before we do that, determine whether -2, -1, and 3, 1 are solutions of the systems of linear inequalities. So if we look at the point -2, -1, okay? Easiest thing to do for this would just be to plug this in and see if it works. Alright, but you've got to plug it into both equations here to see if they work. So, -1, is that greater than -2? Yes. Alright, then we go to our next one. 2 times -2 plus -1, is that greater than -2? -4 plus -1 is -5, is that greater than -2? No. Now here's the whole point of this. That point, for that to work and be a solution of this system, has to work for both of them. It does not work for the second one, so this point does not work at all. Alright, let's try the other one. For the point 3, 1, well, we plug that in, 1 greater than -2, yeah, that is the case. Our other one, 3 times 2 plus 1, is that greater than -2? 6 plus 1 is 7, greater than -2? Yes, that also works. Because that works for both of them, then the point 3, 1 is a solution of this system. Well, say we go to this next one, and we want to know, basically what this is saying is, we want to know all of the solutions to this problem. Not just pick and choose them, we want to know all of them. Alright, so first thing it says is graph the system of linear inequalities. So x plus 3y less than -6. Well, your first job there is to get that on the graph. And what most of you are doing now is you're putting this into slope-intercept form. So if we work with our first one here, we've got 3y less than -x minus 6, and then you're going to divide everything by 3. So we've got -1/3 x minus 2. And then you graph that out. So our slope, our y-intercept is -2, and our slope is -1/3. So that means we go down 1 and over 3. Down 1 and over 3. Alright, and we draw that line in there. Alright, now with this is just a less than though, it's not less than or equal to. So we have to not have a solid line there. We need to have a dashed line. So make sure you show that on your graph. Alright, for our other one, y is greater than -1/3 x plus 2. Well, that's already in slope-intercept form. We go up to, our slope is -1/3. And drop that line in. Alright, and that one can be solid because of this equal sign in there. Alright, so then what we gotta do is we've got to finish shading this in here. Alright, so for this first one, if you remember when we did this before with just one of them, I told you to pick a point that's not on the line. Alright, so if I plugged in the point into this equation here, which remember that's the bottom one, I plugged in the point 0, 0. 0 plus 0 is less than -6. So is 0 less than -6? No, that's not true. So because that's not true, then 0 is not going to be a point, and every point outside, or on the other side, is going to be a point. Okay, y is greater than or equal to -1/3 x plus 2. Which way are we gonna shade it on that one? Well, we do the same thing. 0, 0 isn't on the line there, so we can use that. 0 is greater than 0 plus 2. Well, that's not the case either. Alright, and what we do for this one is we would shade not on the 0, 0 part, we would shade on the other side. Okay, now what we're looking for is we're looking for the solution set to this problem. Alright, and when we're looking at the actual graph, we're looking for where do those two shaded regions overlap? Because what we want is we want to know all of the points that work for both of them. As you can see, there isn't going to be a point at all on this entire graph where those two overlap because those two lines are parallel. So then our solution set is no solution. There's not going to be a point where those intersect. Say we go to this next one. We're doing the same concept. Graph the system of linear inequalities and describe the solution set. We're gonna do the same thing. Alright, so let's see, I'm gonna add the y over and subtract the 3. So then I've got x minus 3 less than or equal to y. Down here I'm gonna subtract the x over, so y greater than or equal to negative x minus 2. This last one, y is less than or equal to 2. Alright, so for our first one, we'll go down 3, and then our slope is 1. So up 1 over 1. Our second one, our slope, our y-intercept is -2. Our slope is -1, so that's coming down this way. And then our y is less than or equal to positive 2. That is going to be going straight across here. Okay, all of those are equal to, so we can leave them as solid lines. Alright. Now we just gotta figure out where the shaded region is gonna be. Nice thing is 0, 0 isn't on any of those lines. So if we plug in 0, 0 here, 0 minus 3, so that's -3, is less than 0. Well, that's true. So that was our first line. So that is going to be everything above this line. Okay, for our next one, 0 is greater than 0 minus 2. 0 is greater than -2. That's also true. So we are going to shade in on this side of the second line here. Alright. Now, as you can see, we've got a region where it does overlap, right? It's everything above this V here. Well, we still got this third one to go. Y is less than 2. Well, that's going to be everything below. So if we shade all of that in, then hopefully this works. We can see everything here. Where is the shaded region where all three of them overlap? Well, that's going to be right in this area right here, this triangle right in the middle. Okay? And that, everything inside that triangle and on the line would be a solution to that problem. Okay? Your graph is your solution here. Alright, so that would be our solution. We need to make sure that is on the graph to be able to show what the solution set is. Alright, word problem. 2 of the ticket prices for a 2007 New York Yankees baseball game were $62 for a box seat and $15 for a bleacher seat. Suppose you're a softball coach. You want to buy tickets for the team. You decide to buy up to 20 tickets and spend up to $600. Let X represent a number of box seats and Y represent a number of bleacher seats. Write and graph a system of linear inequalities to represent all the possible combinations of box seats and bleacher seats you can buy. Alright, well, that's a lot of information. We need to come up with some equations for this situation. Well, the first thing that I would recommend you do is this problem is nice because it tells us what X and Y are. If it doesn't, you need to be able to tell what each one of those are. Alright, because when we come back to reading your graph, we're going to know what's X and what's Y. Alright, so then we got to make some equations here. Well, one thing it does say is you decide to buy up to 20 tickets. You don't have to buy 20 tickets, but I would guess there are 20 girls on the team, and you know, if everybody goes, well then we're going to need up to 20 tickets. So what that would mean is, for our equation, X plus Y up to 20. Does that include 20? No, that doesn't include 20, and because of that, it's not going to be more than 20, it's going to be less than 20. So we've got X plus Y is less than 20. If we flip that into slope-intercept form, Y is less than negative X plus 20. For our other one, we do the same thing, except we're going to be dealing with prices now. We know that we can spend up to $600. Once again, not equal to 600, and definitely not more than, so it's going to be less than $600. $62 for a box seat, and $15 for a bleacher seat. Alright, now this is one where I don't think I would put it into slope-intercept form, because you're going to have a mess no matter what with that one. What I would do instead is I would find your intercepts. So if I put, say for example, I put a 0 in for X, what would I get for Y? Well, I'd take 600 divided by 15. That gives us a 40. That's not so bad. Alright, but the other one's going to be a little bit messier. When I put a 0 in for Y, and then take 600 divided by 62, that gives me approximately 9.7. Alright, but because we have those 2 points, we can put it on the graph. Alright, from here, now you gotta say, well, I'm not graphing 40 on this regular graph here. I've got to spread this out a little bit, or shrink this down so I can get all my information on the graph. Maybe what I would do instead is, instead of counting by ones, maybe every other line count by tens. And then I can get all of this 40 on there. Okay, and the same thing over here. And then we're going to get those two equations on our graph. Well, 0, 40 is up here. 9.7, so a little bit less than 10, so give it a guess. Alright, and then connect those points. Alright, negative x plus 20, so our slope is negative 1, our y-intercept is 20. Alright, now, because our dimensions, because we moved up 10 every 2 and across 10 every 2, what we can do with our slope of negative 1 is we can still go down 1 over 1, down 1 over 1, and so on here. Alright, and then we can draw this line in here. Alright, so that's a nice little trick that can save you a little bit of time when you do that. Now we gotta figure out where's the overlapped region. Alright, once again 0, 0 isn't on either one of the lines. So if we plug that in here, 0 plus 0, 0 is less than 20. Yep, that works. So then shade that in, that's going to be below this region, or below that line. So we're down here. And then for our other one, 0 plus 0 is less than 600. Yeah, that's also true. So we've got everything to the left of this line. Alright, and then the question is, where's our overlapped region? Well, our overlapped region is in here, right? So it's where this blue area is. So you could go in and say, well, if you buy that number of tickets, then for any one of those ordered pairs, so for example, this point right here, I know it's hard to read, but if you said, well, if you go and buy 5x and 0y, so 5 box seats and 0 bleacher seats, that would work. And it would, because it'd be less than 20 tickets, and 5 times 62 is 310, so you'd spend less than $600, that'd be totally fine. Or say that you wanted to use this point 510. That's still 15 tickets, so it's less than 20. This is 310, this would be 150, so that's what, 460? Still less than $600, so you could do that. Okay, so anything in that blue section works? Well, not quite. Alright, can you buy, so for example, this point right here, we're saying that that would work? 10, 20, 30, so we can buy a negative 40 tickets and a negative 35 tickets? No, you can't buy a negative amount of tickets. So we need 2 more equations here. We need to say x is greater than or equal to 0 and y is greater than or equal to 0. And then those are our 4 equations that we need to be able to solve this problem. So then when we plug that in, that would mean, well, we've got this line, and we've got this line. So then it's to the right of this line and above that line. That means we've got this tiny little area. This kind of right in there. So approximately all of that black area right there. And that would be the answer to our problem. Alright, these take a little bit more work. Make sure you grab enough graph paper to do these. Any questions, let me know.